Hello educators, learners, welcome to your Maths Pathshala. Encode Maths. Let's learn maths. This is my first class of Maths on YouTube, and today we will discuss about number systems. But before that, did you all know what is a number? What is the need of number? Why we learn numbers? Okay, let me tell you. Numbers are nothing basically an identity to assign in the form of symbols. Right? Okay, let me more simpler. Suppose there are so many students in your classroom. How could you recognize them? By calling their names or by calling their roll numbers, right? Suppose your class teacher call a student by his or her roll number. Automatically your mind started recognizing him or her after listening his or her roll number, right? So the idea behind numbers are only to give an identity in the form of symbols. Further, there are so many uses of numbers, like numbers are used to count something. Numbers are used to assign a order. Numbers are used to give them a order, right? Number systems are represented on the number lines, like all the numbers you can draw on the number lines. So if we draw a number line here, take 0 as the origin of this number line, and if we move towards the right hand side from this 0, we got all positive integers, right? And if we move towards left hand side from the 0, we got all negative integers, right? Moving towards left hand side, we got negative integers, and moving towards right hand side at this number line, or this from towards the origin to the positive hand side, we got all positive integers, right? So this number line if we moving towards the right hand side on this number line, this line move towards infinite, right? And if we move towards left hand side, it also goes to infinite. But I had already told you that when we move towards left hand side at this number line, we got all negative numbers, right? That's why this infinite has a negative sign. That means it moved towards negative of infinite, right? And here if we moving toward right hand side, we got positive numbers or positive integers. That's why this has a positive sign. That means if we moving towards right hand side at this number line, we can go at positive infinite. Let me explain you here that infinite means it doesn't terminate at the fixed point. That means it goes towards some xt point. Okay, so you all know that moving towards the right hand side on this number line, we all got positive integers, and moving towards the left hand side, we got negative integers. But before that, I'm going to tell you that what does this integer means, right? Integers are the complete numbers without having any fractional or decimal part. Okay, like 1, 2, 3, 4, 5, and 0, -1, -2, -3, like that. 0 itself an integer, because these numbers are in a complete form of set, without having any decimal portion or without having any fractional part. You know what I like? 0.2, you can also write it 2 by 10, like so. This is decimal and this is what? A fractional representation. So these two are not included in a integer. Integer itself a complete number. without having any fractional portion or without having any decimal portion. Okay, further moving towards, we will talk about a variety of integers like positive integers. We can assign them as like this: positive integers. Integers can be represented as I, the capital I. Capital I is the representation symbol used to represent integers. Okay. In the same way, for negative integers, again we can represent as I. And zero integer. So concluding positive integers, negative integers and zero, this all comes inside integers. As I said, integers doesn't have any fractional portion or any decimal portion. So you can say on a number line 0, 1, 2, 3, like that, -1, -2, -3, like that, moving towards right hand side, moving towards left hand side, including 0, are all integers. Now there are so many numbers or number systems, like variety of numbers are there in the number system, and the very first number system, that is natural numbers. Okay, so what is a natural number? Basically, the numbers we most of the time we use the numbers like 1, 2, 3, 4, 5, 6, 17, 21, 104. These all numbers are natural numbers. Naturally, in our mind, we start counting. For the counting purpose, we use the numbers are natural numbers, or you can say those numbers which are used for counting purpose are called natural numbers. Example: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. So these all numbers are natural numbers. The basic definition of natural number is that the numbers which are used for counting purpose are called natural number, right? Okay, in other words, you can also say that all positive integers, if we talk about all positive integers, then at the number line we started moving from 0 towards right hand side. Okay, for all positive integers we moving towards right hand side from the origin. So if we move towards right hand side at the number line, after 0 what does comes? 1, after that 2, 3, 4, like that. So for the natural numbers, you also can say that all positive integers are called natural numbers. Okay, in this section I can say some basic properties related to numbers, natural numbers also, like if you started adding two natural numbers, if you trying to add two natural numbers or two counting numbers, what did you get? Let's an example. Let's 2 is a natural number, again 3 is a natural number. So let's add them. 3 plus 2, we got 5 here. So 5 is what? It's also a natural number, right? So the basic idea is that on adding two different natural numbers, we always got a natural number, right? Okay. In the same way, if we multiply two natural numbers like 2 into 3, we got 6 as a result. 6 is also a natural number. If you go to the definition of natural numbers are all counting numbers, or you can say all positive integers are natural numbers. So if we multiply two natural numbers, we got another natural number as a result. So always remember that on adding or multiplying two natural numbers, we got another natural number as a result. Further, if we talk about subtraction, so is it possible that after subtracting two natural numbers, we always got a natural number? Let's check it. Okay, take 2 is a natural number and subtract 3 from 2. 3 is also a natural number, 2 is also a natural number. We got what? -1, because the negative integral value is higher than positive integral value. So after subtracting 2 minus 3, we got -1 as a result. Is -1 a natural number? No. If we talk about the definition of the natural number, we already told you that all positive integers are only natural numbers. So -1 is not a positive integer. What does it is? It is a negative integers. So it cannot be a natural number. Okay, remember that. So after subtracting two natural numbers, we doesn't get a natural number. But somehow let's subtract 5 minus 2. We got 3 as a result. 3 is a natural number. Here is it possible, but in the previous case, we doesn't get the natural number as a result. We got a negative integers. In the same way, if we talk about the division of two natural numbers, let's check. Does we get a natural number as a result after dividing two natural numbers? Let's check. 6 is a natural number. We divide it by 2. We got what? 3 as a result. 3 is a positive integers. Okay, so it is a natural number. Let's check another example like 6 divided by 4. Okay, is it possible that you can get a integer as a quotient? No. Let's divide 6 by 4. 2 3s are 6, 2 2s are 4. Again you divide 3 by 2, you got 1.5 as a result. Or you can say 1 plus 1 by 2 as a result. So here 1 is an integer, but 1 by 2 is not an integer. It is a fractional number. Or you can say 1.5 is not a complete integer. It is a combination of integer and decimal both. That's why in the case of division of two natural numbers, it is not possible that we got natural number as a result always. So now we can conclude that addition and multiplication of two natural numbers got natural number as a result. After adding two natural numbers and multiplying two natural numbers, we got natural number as a result. But in the case of subtraction and division, it's not always possible that you got natural number as a result. So always remember that these the important properties of natural numbers, right? So let's discuss the next number, that is whole number. As you all know, natural numbers, what is it? It is all the positive integers are called natural numbers, or the counting numbers itself are called natural numbers. But you know, natural numbers are started from 1, 2, 3, 4, 5, 6. That natural number always start from 1. So is it possible that 1, 2, 3, 4, 5, 6 can complete all the numbers? No. But when we include 0 with this natural number, natural numbers, if we take 0 itself with these natural numbers, we got what? We got whole numbers. That means whole number is what? All the natural numbers including 0 itself is called whole numbers. That means if we include 0 in the natural numbers, we got what? Whole numbers, right? Only 0, after including 0 in the natural numbers, we get whole numbers, right? Okay, so another number is a prime number. Let's discuss about prime number. Let's understand it very sincerely, because this number always make a misconception, or it takes time to understand that what kind of number that is prime. Okay, so the basic definition of prime number is that a number which is divisible by itself and one only are called prime numbers. Okay, let me give you an example. Let's take 3. Check 3. 3 is itself divisible by 3 and it also divisible by 1. So 3 is divisible by itself and 1. So a number which is divisible by itself and 1 only are called prime numbers, right? Number which is divisible by itself and 1 only are called prime numbers. Okay, another explanation of prime number. So another explanation of prime number is that you can say prime numbers has always only 2 factors. That means number that is prime has only 2 factors, right? Let's check this by an example. Suppose 7, we have a number 7. So you can say 7 is divisible by 7 and 1. That's why this is a prime number. In another way, you can also say that 7 has only 2 factors, 7 and 1. That's why this is a prime number. So you can say that each prime number has only 2 factors. If a number having more than 2 factors, then it cannot be a prime number. Now I can explain you a variety of prime numbers. As by definition, prime number is a number which is divisible by itself and 1 only, and in another way you can say that a prime number has only 2 factors. Let's say 3 is a prime number, 5 is a prime number, 7 is a prime number, again 11 is a prime number, and so on, right? But before that, a number 2 is here. 2 comes. What can you say about 2? Is it a prime number? Let's check. 2 is divisible by 2 and it is also divisible by 1. Or you can say 2 has only 2 factors, 1 and 2. So by this definition, 2 is also a prime number. But it is very special prime number. It is a special prime number. Why it is special? Because 2 is an even number, right? 2 is an even number, and rest other prime numbers after 2 all are odd numbers, right? After 2 you cannot say that any other even number is a prime number, right? So that's why 2 is a special prime number, because it is divisible by 2 and 1 right? And it has two factors, only 1 and 2, and it is also an even number. About even number, as you all know that even number is those numbers which are divisible by 2 are even numbers, and those numbers which are not divisible by 2 are called odd numbers, right? So in the series of prime numbers, only 2 is the even prime. That's why it is a special prime number, or you can say the prime number starts from 2, but after 2 the rest prime numbers can never be an even number, right? So in the series of prime numbers, the prime number starts from 2, and after 2 the another rest prime numbers all are odd numbers, right? Okay, now moving to the next number, which is also very special number, that is composite number. Composite numbers are those numbers which having more than 2 factors. The numbers which having more than 2 factors are called composite numbers, or in another way you can say that composite numbers are those numbers which are divisible by itself and 1 and by some another number also. The numbers are called composite numbers. By an example, let's take 4. Check, 4 is divisible by 2, 4 is also divisible by 1, and 4 is also divisible by 4. So here you can say that this number 4 is divisible by more than 2 numbers, or you can say this number 4 has having more than 2 factors, right? 2, 1 and 4, 3 factors are here. That's why this is a composite numbers. In the case of prime numbers, there was only 2 factors, or the number was only divisible by itself and 1 only. But in the case of composite numbers, the number is divisible by itself, by 1 and by some another number. So 4 here is divisible by 2, right? So this number 4 has having more than 2 factors. That's why these numbers are called composite numbers, right? So let's take another example. Let's check 6. 6 is divisible by 2, 6 is divisible by 3, and 6 is divisible by 1, and 6 is divisible by 6 itself. 6 is divisible by these 4 numbers. So here the property says, the condition fulfills, like the number 6 is divisible by more than 2 numbers, or more than 1 and itself, or you can say 6 has 4 factors. So this number 6 is also a composite number. But always remember that, let's check, 2 is a prime number. 2 is a prime number, as you all know. Let's check, it is a composite number. No, because 2 is divisible by 2 and 1 only. No another number can divide 2, right? So it is the condition of prime numbers where only 2 factors are there, right? So 2 is not a composite number. Let's move to the 3. 3 is again a prime number because it has only 2 factors, or you can say it is divisible by only 2 numbers, 3 and itself, and 1 only. So 3 is not a composite number. 4 is a composite number, as we already discussed. 6 is a composite number. So the definition of composite number is that a number which is divisible by itself, 1 and by some another number also are called composite numbers, or the numbers having more than 2 factors are called composite numbers, right? So always remember that prime and composite numbers are a special case of number systems. So one more thing you have to remember, that 1 is the number which is not a prime number and it is not a composite number, right? So 1 is not a prime number and it is also not a composite number. Sometimes in many examination it is asked that is it 1 a prime number, is it 1 a composite number? So you have to remember that 1 is neither a prime number nor a composite. So these are some quick facts you have to remember, because these quick facts based questions are usually asked in many examinations. Like, what is the first prime number? So you all know that 2 is the first prime number and it is also a even number. So you always remember that 2 is the special prime number. Okay, this is the first prime number in the series of prime numbers and it is always an even prime number, right? Usually all remaining prime numbers are odd prime numbers. And in exams, so many examinations, it is also asked that between 1 to 100 how many prime numbers are there. So always remember that between 1 to 100 there are 25 prime numbers. If you start from 1 to 100, you can get 25 prime numbers. Between 1 to 1000, how many prime numbers are there? If someone asks you that how many prime numbers exist between 1 to 1000, then you can say there are 168 prime numbers. 168 prime numbers lies between 1 to 1000. Okay. And if we talk about the composite number, so the first composite number is always 4, right? And between 1 to 100, how many composite numbers are there? If you count, if you check from 1 to 100, so how many composite numbers are there? Let's say there are 74 composite numbers lies between 1 to 100. And if you check 1 to 1000, how many composite numbers are there? If you check between 1 to 1000, how many composite numbers are there? So there are a lot of composite numbers lies between 1 to 1000. Even if you start counting between 1 to 1000 about composite numbers, there are so many composite numbers. So you only have to remember that there are 831 composite numbers. Total 831 composite numbers lies between 1 to 1000. Okay. So these are the quick facts usually asked in mini examination regarding prime numbers and composite numbers. And about even numbers, in a very short way I can say even numbers are divisible by 2 and odd numbers are not divisible by 2. Okay, remember that. So this is all about the number systems. These are the basics of number systems, and in the further classes I will explain more about the remaining types of numbers in our number system. Thank you for watching this video. Hope you like this video. So we will continue this number system series in further classes. Still stay tuned to this Encode Maths and keep learning mathematics. Thank you.